This is a review for your upcoming test on definite integrals, antiderivatives, and the fundamental theorem of calculus. The goal of this is to show you how to work through each one of these problems and see how to approach each one of these. I have provided a link on Schoology that will have links with timestamps to each one of these questions, so that instead of having to scan through this particular video, you can go through and just click, and that should link you exactly to where you need to be. So without further ado, let's start looking at these questions. So one of the first things that you need to be able to do is you really need to be able to figure out how to do a trapezoidal sum / Riemann sum, all of that stuff. So in this question, we're looking at closed interval from 2 to 8, has values that are given in the table above, using the subintervals 2 to 5, 5 to 7, 7 to 8. By the way, typically they won't mention it that way. They'll say using 3 subintervals. What is the trapezoidal approximation of the integral from 2 to 8 of f of x dx? So what you do is you'd realize I've got these intervals with the x values, the change in x's being 3, 2, and 1. And we can say that the integral from 2 to 8 of f of x dx is approximately, and we can write down the trapezoid. So this would be a base 1 and a base 2 for this first region. So we have a height of 3, 30 plus 10 over 2, plus the second interval between 5 and 7 would be 2, 30 plus 40 over 2, plus the final interval with a height of 1, 40 plus 20 over 2. So right here, 30 plus 10 is 40, divided by 2 is 20, 20 times 3 is 60, plus, those will reduce, 30 plus 40 is 70, plus 40 plus 20 is 60, divided by 2, giving us 30. Add those together and get your final answer of C, 160. All right, question number 2. Question number 2, we're given a graph of the function f showing horizontal tangents x equals 2, x equals 5. Let g be the function defined by g of x is equal to the integral x from 0 to x f of t dt. For what value of x does the graph of g have a point of inflection? So point of inflection means either g double prime of x changes between plus and minus, or g prime of x changes between increasing and decreasing. So when I look, I've got the relationship g of x is equal to the integral from 0 to x of f of t dt. So for this question to work, we need g prime of x, which when I take the derivative of that integral, simply is f of x. So if f here is really g prime, then I can see that there is a change increasing to decreasing here at 2, and also a change down here at 5, where we go decreasing to increasing, making our answer C. Question 3 is asking us to simply find that integral. One thing to be careful of, we've learned how to do natural log. Please do not tell me that this is the natural log of x squared. That is not the case. What we need to do is we need to rewrite this problem and realize that this is x to the negative 2 dx. This follows the simple power rule of x to the negative 1 over negative 1, evaluated from 1 to 2, or put a slightly different way, negative 1 over x evaluated from 1 to 2. I'm going to pull out the negative here, call this 1/2 minus 1. 1/2 minus 1 is negative 1, so I get negative, 1/2 minus 1 is negative 1/2, so I get a double negative there, giving me a final answer of C, 1/2. All right, moving on, we're going to take a look at question number 4 now. This one's a little bit scarier. Find integral from 0 to 2 of 3x squared f of x cubed dx. If the integral from 0 to 8 f of t dt is k, that doesn't look very straightforward at all. But when I look at this, one of the things I do notice is I see a chain rule piece. If I were taking the derivative of this, yeah, there's a product rule, but there is a chain rule. And when I see a possible chain rule, I should be thinking to myself, well, that maybe is a u sub. So let's check and see what happens if I u sub that. If I pick my u to be x cubed, my du would be 3x squared dx. And you'll notice that 3x squared is right there. So I could rewrite this integral simply the f of u du. But remember, if I do a problem with a u sub, I need to figure out what happens when x is 0. Well, then my u, which would be 0 cubed, would be 0 as my lower limit. But when the x is 2, my u, being 2 cubed, is 8. So I wind up, after the u sub, getting the equation, I get the expression integral from 0 to 8 f of u du. And if I compare those, the only difference here is the t to the u. Now this is kind of weird. Basically, the concept is that the variable doesn't really matter all that much. Everything else is the same. It's still the same function, still the same limits. It's just that the dependent variable is under a different name. But because that matches perfectly, we can say our answer is D and call that a day. All right, next up we've got question 5. Question 5, just like question 3, is a straight up antiderivative. It's already x to the negative 3, so I take the antiderivative of that, call that x to the negative 2 over negative 2, evaluated from 1 to 2, or rewriting that negative 1 over 2 x squared, evaluated from 1 to 2. I'll factor out the negative 1/2, evaluate that as 1 over 2 squared minus 1 over 1 squared, or negative 1/2 times 1/4 minus 1, which is negative 1/2 times negative 3/4, which after multiplying that through becomes 3/8. Now we're taking a look at question number 6. If negative 2 to 2 of x to the 7 plus k dx is equal to 16, then k is something. So essentially what I want to do is I want to figure out what on earth that is going to be. Now there's a few ways we can attack this. The way I personally would, is I suppose you could always just pick some of these variables, but that would be really, really hard and I wouldn't want to do that. But what I would do is I would take the antiderivative of x to the 7th plus k. So that would become x to the 8th over 8 plus k times x, and I would evaluate this from negative 2 to 2. So if I do that, replacing all the x's with 2, I'd get 2 to the 8th over 8 plus 2k minus negative 2 to the 8th over 8 minus 2k. Well, I know that if I simplify this down, I get 2 to the 8th over 8 plus 2k. Cool, that's neat. And over here, negative 2 to the 8th is actually going to become a positive 2 to the 8th over 8, but because of the minus sign, we would get negative 2 to the 8th over 8, and we would get plus 2k. And you'll notice that the 2 to the 8th over 8 reduce, leaving me with 4k. And I know what that's supposed to equal. It should equal 16, making k equal to 4. On to question 7. If f of x equals the integral from 0 to x squared square root of t plus 3 dt, what is f prime of x? So to go from f to f prime, I need to take the derivative. So I'm going to take the derivative with respect to x of the integral from 0 to x squared square root of t plus 3 dt. And right there, that should scream to you that this is, in fact, a second fundamental question. So when we do second fundamental, we replace the t with the x squared, my limit, and then using the chain rule multiply by that limit, the derivative of that limit to get 2x. And we can see the answer should be C. Next up, we're going to take a look at question number 8. This is a straight up, if I take a look, I can see there's my chain rule right there. That would be a chain rule application, so that tells me that this is a u sub. U is going to be 3x. du is going to be 3dx. So we can rewrite this problem as 1/3 of the integral of the sine of u du, where we would set the x equal to 0 and evaluate u at 3 times 0, which is 0, and evaluate x at pi thirds, u being 3 times pi thirds, making this pi. So now that I've rewritten the problem as a u sub, I take the antiderivative of sine, which is negative cosine of u, evaluate it from 0 to pi. I'll factor out the negative, call this negative 1/3. Cosine of pi minus cosine of 0. Cosine of pi is negative 1. Cosine of 0 is 1. Negative 1 minus 1 is negative 2, giving me a final answer of 2/3. Following that up, we will take on question 9. Continuous function f of x. So this is kind of a weird looking one. When I take a look at that, I've got a continuous function that's telling me I can use the fundamental theorem. That's what that's telling me. I notice again, I see chain rule in this problem, so I'm already thinking, you know, u sub sounds pretty darned good. So this becomes, if we rewrite that, that becomes half of the integral of f of u du, reevaluating the endpoints. When x is 1, you get 2 times 1, which is 2, and when x is 3, 2 times 3 is 6. So we rewrote the problem as a u sub question. And what they're trying to tell us here is that if I integrate f, then that would mean I would integrate f prime, and the integral of f prime is capital F. So I could rewrite this as 1/2 capital F of u, evaluated from 2 to 6, or half of f of 6 minus the f of 2. Now I don't see that answer anywhere, but I'm pretty smart. I understand that I can distribute that, giving us answer choice E for this next problem. All right, we're up to question number 10. This is another very straightforward. I started with f is defined as an integral. I'm asking for f prime, so I need to take the derivative here, the second fundamental. This is a really, really easy second fundamental because it's just an x, not a chain ruled x. So this is just x cubed plus 1 is our, I apologize, we should call that not lowercase f, but capital F prime of x. The question asks for f prime of 2, so square root of 2 cubed plus 1 is 3. We call that one a day. Question number 11 is probably the hardest one out of all of those. When we take a look at this, this looks weird. Integral from 0 to pi over 4 e to the tangent x over cosine squared x dx. Now I'm looking at this and I'm going, is there a chain rule? And I see there's two possible chains, cosine squared and a tangent. Now that's an e function, so one of the things I'm hoping that you've recognized is that when you have the e function, you're probably going to use that as your basis for your u, because there's no way to really manipulate that question, and I can't integrate natural log, so I'm really stuck. But then I get something weird. I get du is the secant squared of x dx, and I don't see a secant squared, so I feel like I did something wrong. And that wouldn't be the case here, because you see, that integral, I'm going to cover up the is here, can actually be rewritten as e to the tangent of x times, and the divide by cosine squared is the same thing as secant squared of x dx. So what they were trying to do is trick you right there. This becomes e to the u du, and I have to evaluate when x is 0, I need to figure out u, which is the tangent of 0 which in this case is 0. And I need to evaluate x at pi fourths. So u is my tangent of pi fourths, which in this case is 1. So when I look at the question, I simply get e to the u evaluated from 0 to 1, or e to the 1 minus e to the 0, which is 1, e minus 1. C has to be our solution. Okay, moving on, we are up to question number 12 now. This is a weird one, absolute values. I don't want to write this as the split absolute value. I don't want to make this into a piecewise function. So, my hint for you with absolute values is to draw the picture. I'm going to go from 1 to 4. If I select a 1 for x, then 1 minus 3 is negative 2. But of course, this is an absolute value, so it becomes positive 2. When x is equal to 0, or when our function equals 0, x has to be 3. And at the other endpoint of 4, get a value of 1. And as you can see, our problem simply becomes 2 triangles. This is a 2 by 2 triangle, so this becomes 1/2 of 2 by 2. Plus this is a 1 by 1 triangle, so this is half of 1 by 1. Or 2 plus 1/2, which is 5/2. All right, we are now moving on to question 13. Question 13, if f is a linear function, then the integral from 0 is less than b is less than a, then the integral from a to b of f double prime. This is the trickiest conceptual question. So the trick here is to realize linear function, which means that there is no concavity. Can't have concavity if I'm a line. There's no curve. And if there's no concavity, that actually tells you that f double prime of x is going to equal 0. Well, and if f double prime of x equals 0, f prime of any x function, if we integrate it, should be some constant c. And it won't change. If we integrate that, if we integrate 0, we get 0 plus c. So then I'm like, well, if I look at this, this may be by first fundamental f prime of b minus f prime of a, so then I'm really confused. I'm like, well, what is this? But if I understand this piece right here, I realize that f prime of b is some c value. It's the slope of whatever that line is. And f prime of a, that's some c value. Which c value is it? It's still the slope of the line, and the slope of the line never changes. So c minus c actually turns into 0, and your answer is A out of all possible things it could be. All right, where are we up to? We are up to question 14. I'm not going to spend much time on that. That's secant squared is tangent. Look it up. All right, cool. That was quick. Looking at the next one, 15 here. If f is a continuous function that is defined for all real numbers, with the integral from 1 to 3 of f of x dx equals 5/2 and 1 to 5 of f of x dx equals 10, then the integral, oh my goodness, so there's a lot. There's so much. You know what I'm going to do? I'm actually going to look at a new flip chart just so we can have that one a little more handy. So what am I looking for? I'm looking for the integral 3 to 5 of, and man, they're even using brackets here. Man, this is going to be all sorts of whack. 2f of x plus 6 dx. So I know that this is the integral from 3 to 5 of twice that integral f of x dx plus the integral from 3 to 5 of 6 dx. This is something from the previous test that this should not be a surprise at this stage. Well, if this has a distance of 2 from 3 to 5 times 2, I know that that's at least, or times 6, I know that's at least 12. So what I need to figure out is what on earth is that integral. And that's where the other pieces of information come in, because I know that from 1 to 5 f of x dx, that's really the integral from 1 to 3 f of x dx plus the integral from 3 to 5. And what I really need to figure out is what on earth is this, because I know what this is. That's 10, and I know that that's 5/2, plus I'm going to call that just some x value, in which case that x value should turn out to be 15/2. So this is 15/2. I've got 2 times 15 over 2. 15 plus 12. And if you check out our review here, you'll notice 27 is a possible answer choice. Likewise, we can take a look at 16. And when we look at 16, the integral from a to b of f of x dx equals a plus 2b. Just like the previous question, I really want to split that up. The integral from a to b of f of x dx plus the integral from a to b of 5 dx. Well, I already know what this is. This is a plus 2b. Awesome. But what is this other one? Well, what I can realize that this, I can actually take the antiderivative, call that 5x from a to b, and that's really 5 times b minus a, or 5b minus 5a. So when I look at this, I can rewrite this a plus 2b plus 5b minus 5a, where the a plus 2b is my f of x, and my 5b minus 5a is my integral of 5 dx. a minus 5a is negative 4a, and 2b plus 5b is plus 7b. I need a positive 7b and a minus 4a. Looks a lot like C to me. We're almost there. We are looking at question 17 here. If the integral from 1 to 10 f of x dx equals 4, and the integral from 10 to 3 f of x dx equals 7, this should be a warning sign right here. I'm looking at this. I don't like the order that they put that in. I want from 10 to 3, or 3 to 10 f of x dx, not 10 to 3. So let's go ahead and rewrite that and call that negative 7. So I know that 1 to 10 f of x dx is equal to 1 to 3 f of x dx plus 3 to 10 f of x dx. This is negative 7. This is 4. Add the 7 over. Your answer turns out to be 11. And it's that simple. Nothing crazy there. All right, last couple ones. We are looking at 18. Wow. I'm looking at that problem. Again, I see a chain rule, e to the negative 4x. I need that to be just a u. I'm going to call that negative 4x. du is now negative 4 dx. So this gets rewritten as the negative integral of e to the 1/4, the integral of e to the u du, where when x equals 0, then u, which is negative 4 times 0, is 0. And when x is equal to 1, then u is equal to negative 4 times 1, which is negative 4. So I can call this negative 1/4 e to the u evaluated from 0 to negative 4, or negative 1/4 e to the negative 4 minus e to the 0, which is 1. Now I got negative 1/4 e to the negative 4 minus 1, and I look down at my answer choices and I see they've messed with it. It looks like I'm going to have to distribute that 1/4, so I got negative e to the negative 4 over 4 plus 1 over 4, and that would be our answer choice D. So that wasn't bad. All right. Number 19. Again, this is not a terrible question. You just have to know the antiderivative of sine, which is negative cosine of t, evaluated from 0 to x, which is, and what students will do is they'll just say, oh, it's got to be negative cosine of x, but I didn't take the derivative of this, so it's not the first fundamental, second fundamental. This is actually first fundamental, negative cosine of x minus the cosine of 0, which is 1, and when I distribute the negative, I get the negative cosine of x plus 1, which looks a lot like answer choice E. And finally, number 20. Probably my favorite question out of the bunch just because it's kind of strange and fun. If I'm looking at this integral, I'm realizing I want to split this up, negative 3 to 3, f of x dx plus integral from negative 3 to 3 of 1 dx. And what the question wants me to do is, knowing that this is my f of x, what is the integral that they've given me there? So I've split it up, and I realized this integral would be a negative a because it's below the x-axis, a positive b because it's above the x-axis, and a negative c because it's below the x-axis. Here, with this integral, I have to realize that that is x evaluated from negative 3 to 3. So if I do x evaluated from negative 3 to 3, that's really 3 minus negative 3, which is 6. Or you could have realized this is a height of 1, distance of 6, whichever one works best for you. And I tell you that each one of these regions, A, B, and C, have an area, meaning it has to be positive of 2. So negative 2 plus 2 minus 2 plus 6. Those cancel. Negative 2 plus 6 is 4. And ladies and gentlemen, that is the entire review. Hopefully this at least gave you an explanation on how some of these worked and didn't leave you just kind of hanging. Good luck tomorrow on your test, and I look forward to seeing you all on Monday. Thank you and have a great day.